Okay, I think we'll get started. So first of all, it's my great pleasure to welcome Luigi here from Torino in Italy, where when he's not leading the eLight research group, he is also deputy head of department and executive vice president of SIGCHI and an associate editor for IJHCS. So somehow between all of those things, he manages to do some research, which he's going to tell us about today. So over to you. Thank you very much.
Thank you, Anna, for the introduction. And yes, I will try in 40 minutes or less to present you a slice, let's say, of my research, which this title that I gave, that was Everything is Personal, or Designing Customizable Interactive System. And as Anna was saying, yes, I'm deputy head of the Department of Control and Computer Engineer from Politecnico Torino in Italy. And I'm also associate professor there, for which I also do teaching and research, as many of you here. I am an HCI researcher, and my background is in computer engineer. So I'm a computer engineer by background. If you've never been in Turin, that is the nicest picture I could find for the city, even if the university is not visible, is a nice view in a probably sunny spring or summer day. Well, I put here like my social media handle and some things that I like to do. But here we are not going to talk about food or nature or other things. But in this time, I would like to talk about my research, and in particular, my overarching research, let's say, question, that is, how can people make their experiences with computer, with technology, more personal? And I would like to use personal because there are, of course, there is personalization, there is customization, there is custom-tailored system, etc. And all of this means something slightly different from one another. And so I'm trying to use personal or any of this term in an interchangeable way in this meeting for simplicity, because sometimes it's a little bit more customization, sometimes it's something a little bit different. But still the goal is, how can I, as an individual being, as an end user on any system, to make this system more personal, more fitted to me, my needs, and my willingness in that moment. So in this talk, I'm going to cover, let's say, to touch 3 areas in which, in some kind of ways, I applied this customization, that are digital well-being, Internet of Things, and human-centered AI, that is the newest one. So in digital well-being, these 3 areas, the difference that is between these 3 areas is the goal for which I would like to apply some customization effort that could be a different kind or different level. So within digital well-being, my goal would be apply customization to promote a meaningful or a more meaningful use of technology. While in the Internet of Things, the goal of personalization is more towards how can we adapt the environment, physical and virtual environment that we have, to our needs of the moment, to the context we are living it specifically. And finally, sort of related, in human-centered AI, instead, the goal of this customization is more about how we can refine software application in runtime to better fit our current usage of that single piece of technology. And I choose 3 work, because it's 40 minutes and not 3 hours, to cover these 3 areas. So we'll present first Socialize, second version of Socialize for the digital well-being domain, EUPOINT for the Internet of Things domain. There's an experiment study we did with this Zonontologies, a knowledge representation method, and the Morph Guy for the last one. And I choose these 3 work specifically because they show in different way a tension that exists between the intention of personalization of the user and the information needed or used by the interactive system. And these are three different areas, three different ways to approach this tension, and I will hope that we will see it naturally in the talk. Otherwise, I will anyway summarize at the end. So when you will see this the symbol, is because it's something that is specifically around this tension, and it will pop up, especially when I will talk about lesson learned and opportunities for these three areas. So let's start from the first one, digital well-being. So if we want to give a definition, one possible definition of digital well-being is that the impact of digital technology on what it means to live a life that is good for a human being in an information society. And these are, of course, two pieces of information in it that we want to stress. One is that he is a person living a life, living something within his normal, ordinary day, and of course, with technology that has an impact, and not only it has an impact, but it's also part of the society we are living in. So there is this centered on the person within this technological environment. And let me open a parenthesis. If you never have seen this picture, this is a series of photos from a photographer that's called Removed, in which this photographer took picture of people and they removed technology to highlight also the nonsense in some cases of our action. If we just remove smartphone from the ends, that's the results. There's not something you will do without a smartphone in the end. So when we start working on this in 2019, actually, we started looking at what was available around in the market, but also in research. And so we found that there were many mobile applications designed to allowing people to change their behavior with smartphones. And so the first question we asked ourselves was, do they work? And this was a CHI paper in 2019, and the same year, the same conference, there was another paper very similar to this from Oxford University that did something similar to this, but in agreement, in a sense, with this. So what we did was picking the applications from research and on the Apple Store, on the Google Store, etc., and do a functionality review. Then we get all the reviews from the store as well and did an analysis and try to summarize the best functions, the most effective function according to this data. And we create this Socialize app that has two main parts. One was the tracking and visualization of data, that is the one shown here, and the other intervention that were the best intervention according to this, like a timer on the entire phone, where you say, if I use the phone for 1 minute while I'm walking, then tell me that the timer is expired and I'm over this, or blocker at the phone level. I want to always block the phone when at home, in this example, and the same kind of intervention at the app level. So in this case, is setting on a YouTube timer, and after you see a video for the timer, then there is time limit, and you can close the app, snooze the timer, or delete the intervention you create. And we tested it to see the effectiveness of this in an Inderwise study with 39 young adults spanning 3 weeks, where the first week was the baseline data collection of the normal usage of the phone, and the other 2 weeks the application was usable and people can visualize and apply intervention. So do they work? Not really. Not really for a series of reasons, some of them listed here. But essentially we discovered that some of them were useful for some specific use case, but not for others. But they had problems like they are focused on self-monitoring. So you user, you person using this, you have to recognize that you have some kind of problem with, let's say, Instagram, and you have to decide that you want a timer and set a specific amount of time for it, and then be resilient. And when the timers pop up, you don't have to snooze or delete intervention, but apply for this. And so this works until, if you are motivated, and until you keep the application on your phone. As soon as you delete the application, you go back to the previous habit. This is also because these are not grounded in habit formation, nor social support, and they also focus on a single device at a time, so you don't want to scroll on Instagram on the phone and it's blocked, but you open a computer and here you are. You can do it. And also they don't allow the creation of tailored intervention, but you have just timer and blockers for most of the time. So in my research, we take care of different of these aspects. What I want to talk here is about habits, because of this tension I was mentioning before. And so we ask this question, can we discover and mitigate meaningless habitual smartphone use and potentially replace it with something more meaningful? And having the decision what is meaningless or not to the person using the system. So we applied this methodology in 3 steps. First of all, we had to characterize what is a smartphone habit. And we did it also thanks to the literature. And a smartphone habit has 2 parts. One is a contextual cue. There could be time, location, activity, notification, a subset of those. And then when you have this cue, it's followed by a behavioral routine. So what happens between an activation of your screen on the smartphone and the deactivation of the same screen in a session. With this characterization, we use a data analytics methodology on 130,000 phone user session collected in real world to see if these habits pop up and which kind of habits they were. So we ended up with things like the one in the picture. So between 6 p.m. and 8 p.m. when you are at home and when you are still, you typically use Instagram. So we detect this habit, and with this detection, we created a new version of the Socialize app to mitigate this habit, and then conduct in the wild evaluation 3 weeks as before with 20 young adults. And Socialize work in this way. When the application detected a new habits, to show you which is the habit that detected after, let's say, a week, 10 days, etc. And so let's say that detects these habits during a business day in the morning between 10 and 12, you typically use Facebook and Chrome. And you can choose. So here enters the, let's say, customization part. You can choose whether this is a meaningful habit for you, because maybe you are a social media creator and it's normal that in the morning you open up Facebook because you are doing your job, or it's not. And so if it's not, you can press avoid habits and the system will ask you about a motivation. So why you want to avoid this habit. And you can select one of the motivations like I'm bored, or you can also type your own. And then after the motivation, the system asks you for an alternative activity at your choice to do instead of Facebook and Chrome. So for instance, in this example, the user type go for a walk. So during a business day, in the morning, when I open Facebook and Chrome, instead of that, I should go for a walking. And this is something that the user decide to do. And the user can also decide if needs to be notified when this happens with a notification or not. And so when you are in the morning, in a working day, and you open Facebook, if you select notify me, a notification pop-ups that say, remember your goal, go for a walk, or whatever you set up there. So what we found after the study, that in most cases, participants were able to successfully avoid the habits they deemed as meaningless, especially when they enabled the reminder. This use of the application also reduced the smartphone usage in general, which is a nice effect, even if, again, in a study of 3 weeks with 20 people. However, they did not perceive any improvement in their usage habit after the study. So there was an improvement, there was habits that start changing, but they didn't perceive that. So what we can, let's say, learn and what we can think about this. So habits can actually make a difference with respect to the classical traditional approach. We also have seen that people, after they deleted one of these new habits, they continue to have it, and so the use didn't go back to the previous stage. So habit can make a difference. A technological approach could work sometime, and also teaching could be considered an alternative approach, and this is something we are also doing in our research. One thing that was deemed fundamental after the study was this capacity for the people to choose which habit was meaningless or meaningful to them, and this possibility to choose instead of suggesting which habit according to some criteria was better was particularly important in the work. However, this perception of the intervention effectiveness can drive abandonment on the long term. So one idea could be provide information back to the user to set proper expectation. And this closes the first case on digital well-being with this application, where the tension was prompted by the system providing these habits, suggestion of habits to remove or not remove, to avoid or not avoid, and this was tackled since the application provide some suggestion that people can personalize, change, adapt, or not. But in the end, even in this case, there was a little bit of mismatching of expectation because the person didn't feel that this system worked properly and were expecting something different or a more significant reduction. Let's move to the second thing, that is instead Internet of Things. So again, if we want to define Internet of Things, we can use this definition that say that is a complex network of physical and virtual entities involving people, could be developer and end users. So in this definition, we have object in the room, object in the space, and also virtual entities like, again, mobile applications, weather forecasting, etc. So here the goal of personalization in this example is to have people adapt their environment, their IoT environment. So what's the normal way, the traditional way to do this? The traditional way to do this for end user that don't know, that aren't programmer and don't want to be programmer and want to learn how to program is to use system for trigger action rules and variation. So for instance, if the sensor of that door detects that it's open, then turn on the light, which is not far from the intervention of the previous example. If the timer, if I stay on Facebook for 1 minute, then do something. But still, here is more explicit and more open to which are the actual usage. So which are the challenges here? There are two main challenges. One is related to abstraction, and one is, of course, related to support. The challenge of abstraction is that, again, linked with the intention of personalization. I don't think that none of us here would say, if the sensor on the door detects that it's open, then turn on this light. What probably a person would say if the door is open, or if I open the door. So reason at a slightly higher level of abstraction, or at least different. But the system needs this information, needs how to detect that the door is open. Is it a sensor? Is it the door that gives this information? Is a camera that detects something? Is a badge that unlocks the door? Some way to detect this. And current system doesn't work above this level of abstraction. They ask you to specify which device you want to operate to do some action and not the action you want to accomplish in the end. So the challenge here is about abstraction for sure, and then partially also for support, because there could be many ways to express this personalization intention, but also when you have a corpus of rules, you can have rules misbehaving or interfering with each other and generating, for instance, infinite loops. That is not something that an end user understands what is an infinite loop. And so then there should be some kind of support around that. What I want to focus here is more on abstraction. So moving from if the sensor of the door detected is open to something way more abstract. Like if I enter any defined location or any location where I have control, then set the temperature to 22 degrees. So this is a way higher, the opposite probably, level of abstraction, in which I say if I enter somewhere where I can control temperature, then set the temperature. This would mean that in the lower level representation, I would have, let's say, a rule that say if I enter home, set the thermostat to 22 degrees. If I enter in my car, set the air conditioning to 22 degrees. If I enter in my office, imagine that I have control, remote control on it, then set the temperature to 22 degrees. So this will split up in 3, 4, multiple rules involving different devices. Here is expressed from a goal perspective. When I enter somewhere, I want the temperature set up to this temperature specifically. So what we did was to create an ontology as a way to represent the knowledge and to link the specific devices, the door, the lamp, the thermostat, and this higher intention, like if I enter in a room, what means for a device entering a room, which is traditionally left to the user to think, okay, I enter in a room means I need to select that device. We try to move it to the computer so that the person can say, I enter the room, and the computer say, okay, in this case means this device, this sensor, this camera, whatever. So we create this point ontology as a way to represent this knowledge with these 3 goals: enable higher level of abstraction, allowing the customization by functionality and not by device, and also enabling rules that are context dependent, where context means, in this case, a location and privilege of the users on that location, and also interaction between users itself. So after building that was the easiest part in a way, we also wanted to understand if this high-level representation was actually better than the other one and was preferred or not, and which were the advantages or disadvantages. And as a byproduct of this, so here in this example, you see the high level illuminate the room. That is a very high level concept. And then you have sort of medium level. What it means to illuminate a room? Well, it means turning the light on, means open the blinds, means set a specific lighting level, etc. And then below these, to get connected to turn lights on, there is turn this specific brand on with this specific command and turn this other brand with that specific command. And if you're at home, at work, you may have different devices, different access. So this needs to be personalized to the specific environment you're living in it. But to connect this higher level, illuminate, if I enter a room, etc., we also need this medium level that we skipped in the study. We just focus on the high level and the low level representation. And we did a study. We create a user interface that was mimicking if this and then that, which is and was one of the most popular interfaces for doing this kind of end-user programming, with the Internet of Things. We ran a study with 30 participants, 15 of them with no programming experience at all, and all of them with little to no experience with this kind of interfaces. And we give them 5 tasks to complete in both abstraction introduced by a scenario. And the tasks were more, you want to do this, more than fill out a rules in this way. So you want to that the room is lighted up when you enter it. So something similar to this as kind of task. So they did the study with the user interface, and what we discovered from a quantitative perspective is that the high-level representation was, let's say, better by the number. Better means that user made less errors in defining triggers to fulfill those tasks, and way less errors in defining actions to fulfill those same tasks. And also, participants, change their mind less frequently with the high level. So this back number is the number of times that you reach maybe the composition phase with a trigger and then go back to select another device or select another environment or select another things and then continue. So this back and forth happened less frequently with the high level representation. So by the number, sounds good. By the qualitative results, still sounds good, but a little bit less. So the low-level representation was recognized for the limited expression of personalization intention, because I have to think what I want to do and translate it in a device-centric language. Required too many details. It doesn't say this lamp. It says this lamp of this brand with this ID, etc., etc. And ask to choose for too many options. If you go on if this and that and select lights, you have all the brands that produce lights, controlled lights. So there are many options to do that. And even if we just selected a subset for fulfilling our 5 tasks, participants say this is too many things going on screen. The high-level representation was deemed helpful to avoid mistakes, was defined as simple to understand. However, was also deemed too generic, where people feel to lose control to the system. So when I enter a room, what means when I enter a room? That there is a camera that does face recognition to me, or there's a sensor, and the high-level representation doesn't explain, doesn't help you to understand this or to decide this. So there was too much trusting in the system and too much a loss of control, and linked, of course, with possible privacy issues as well. So again, lesson learned and opportunity, as then also the literature will confirm, people think by goal, by functionality, not by device. So the low-level representation thinks by device, so it adds some extra burden to the people. But we discovered that this actual multiple level of abstraction can work together. We can mix things up, and specifically the middle level representation can be useful to have as a middle ground, balancing this control and this autonomously. Context is still the key point. In doing this study, people say, okay, but they already created a similar rule. Can I reuse this? Can I adapt it? Can I bring this from another person? Or I need to create another one? And the default answer is typically you have to create another one because the device change, etc. But there's still this tension, this balancing between adapting something that already did or reproposing and creating another one. And this study also opened another interesting question that we explored last year that I'm not talking about, unfortunately. That is what happens when you have ambiguous user intention. Like, I would like this room colder or hotter, or I would like to set a cozy ambience in my living room. What is cozy, what is hotter, what is colder is really dependent on many factors, many things. And again, technology support can help. So here, the tension between the intention and the system is within is by design, because this system is a challenge of abstraction. So this system was born to try to solve, to elevate the system capability to the level of intention, and probably did a little bit too much to this. But this is totally different approach from the previous one, where the output was suggested by the application. And finally, as the last example, let's change topic and let's talk about human-centered AI. And again, if you want a definition, this is one of the main definitions. This was provided by IBM. That say that human-centered AI is an emerging discipline focused on creating a system that amplifies and augments rather than displays human abilities. And again, with this, we take hold, again, this example, a specific problem, or again, we explore a specific setting. This is marked as preview because it's not published yet. Everything else was already published. This is under review somewhere. But the idea is this. We have graphical user interface. We have software. And when we want to apply customization, we either have rules, like in the previous examples, of predefined configuration option. You can set up a timer with these fields. You can set up a blocker with this field. You have to say avoid or not avoid. Is much constraining. And so there is a lot of constraint in fixed boundaries. And we ask ourselves, if we pick one simple example, a calendar application, a simpler version of calendar application, can we have more customization option available using generative AI nowadays? So this was an exploratory work. That could be one possible future work in my research as well as topic. But the goal here was to explore how we can leverage large language model to let end users, okay, again, people with no knowledge of programming and people not interested in programming or learning how to program, to refine existing user interface. So to customize the user interface to their specific context, need, and moment and situation. So we started with this exploratory work by picking an application, a calendar, a simple version of a calendar, and deciding that that calendar has a fixed set of features. So if the calendar provides, for instance, a daily view, a monthly view, a weekly view, whatever you can do with this application will never generate a yearly view. So the features are decided by developers and they're fixed. What you can do is change behavior, change appearance, and make it more fitted to your specific needs of the moment. So we created this sidebar, let's say, in a calendar, simple calendar application that is split in two areas. One is what we call static settings, because in our mind are settings that change slowly over time, like typography of colors. Like I don't see very well, I have glasses, and so I would like to have settings, font size, at least of a certain amount of size for that application specifically. And colors as well. Maybe I have some impairments in seeing colors, and this could be taken into consideration. And then we have dynamic settings, what we imagine could change a little bit more frequently, not every day, but more frequently, that are what a component of the interface or the entire interface should do or look like, given the programming behind it. So this is a short demo. So this is the simple application, a calendar application in weekly view. And then you open this up, and you can set typography, you can set color, etc. And then you can select a component. This is very fast. You can select a component that is available, so no new feature, and you can say, okay, I want buttons here, I want this button together, etc. And then you generate the interface. In this case was daily view of the calendar. So moving from the default blue, weekly calendar to the daily version of it. And the sidebar allows you also to go back to the previous version and to reset to the original system. So again, this was exploratory, and we were interested in seeing how people would use it, and especially which kind of personalization we're able to do with this natural language that happens in this small input text here. So not to constrain, again, the customization effort. So we did, in this case, an exploratory study with 18 participants, all of them with little or no programming experience, but they, of course, used LLM, like ChatGPT and Claude and similar, and we gave them 2 customization tasks. So starting from this calendar, we asked them to create the easy one, that is the one on the top, and the complex one, that is the one on the bottom of the screen. And so they had the task to create first the easy one and then the complex one in maximum 20 minutes and with maximum 10 trials. And here we found something surprising, actually. Well, most of the people, so in our mind, all or most of the people, why our hypothesis was that all or most of the people will be able to do the easy task and maybe not the complex one. And instead we were actually surprised because if you look some participants, you can see, for instance, that these 18 participants completed the easy task in 13 minutes and the complex task in more or less the same time, and using a prompt that is more or less of the same length. And this is happened for many of them, with 2 notable exceptions, that like participant 4 wasn't able to complete the easy task and write a prompt that is 40 words, I think, length. It's a very long prompt, 2 trial, and in 20 minutes was not able to create the easy interface. But the same user with a complex task was able to complete it in 30 minutes again, using shorter prompt, and was able to do it well. So what we notice here, and similarly, there was people that was very, very good in like completing the first task, and was too good to complete the first task, and the second task was more difficult to them. What we notice here is that there is a learning curve and a lot of learning from the first task to the second task, especially for the people that tried something in the first task and then didn't work out, and then learned immediately at the second round, 20 minutes after, and did actually a way better job than the one that already did a good work in the first round and continued to do a good work on the second round, or were extremely fast for the easy interface, and then for the complex interface, they instead took a lot of time to complete it. So the one that struggled more at the beginning, that had more success after. And so in the end, after the 2 rounds, the system has been perceived effective and quite intuitive to use by almost everyone, but we noticed this learning curve and initial experience. We also listened for a lot of requests for more example and more guidance. So we kept the fields open because we didn't want to give too much structure, and we also kept the field small because we wanted to encourage people to not to write a lot with 1 line of input field, but still probably used to ChatGPT and whatever, where you can write whatever you want, how long you want. People wrote a lot anyway. So again, this tension between intentional personalization and what the system needs or can do. And in this case, natural language is of course flexible, as we know, but even in this case, way more structure is needed without going back to too much structure, but some balancing between the free form text that we have now, even if split in what to do and how to appear, and the way more structured approach that exists nowadays. And the other things we heard is that it would be better integration between the refinement instruction, the sidebar, and the actual interface, so that people can maybe select and say, I want to change this component with mouse, etc., instead of typing and explaining, oh, I want to change the button at the top left of the corner of the screen. So better integration, more example, more guidance would be helpful. So in this case, again, the tension here is in the natural language part, and even with some subtle approach to say write little, the input field is not big, it still didn't work much for the refinement, but in the end, people were successfully in using the system and appreciate the customization capability. So these are the 3 examples in 39 minutes that I wanted to bring up with you. I could have much more example, but that would take like 3 hours of a talk, and nobody, including me, probably would like to have a 3-hour talk. Before concluding, I just want to say and to recognize and to thank my collaborator, my students. These are just a bunch of the current one that work with me on these and other works in these 3 domains, and without them, of course, very little of my work and my research would be possible and done. And with this, I thank you for your time, your attention, and if you have any question, we still have some time.
Hey, first question.
Grazie. Thank you for the presentation. I am curious about the last application that you presented, the sort of UI customization. I completely understand why you gave this example as a control thing, but I was curious, like in actual applications, how prevalent it is for people to customize interfaces in this way. Do people do it like in a sort of a corporate environment? Do system administrators do it? Or if it's not, what would be like a real world example of a similar application?
So that's a good question, of course. And so there is some kind of customization in corporate, that rigid customization that I was mentioning. So you can disable things, you can enable things, and you allow features that disappear, etc. There's not this level of customization, of course, and this was like exploratory and trying to push a little bit from what it exists. In our mind, this first work was to link back to all the research on adaptive system, and also thinking, especially with the static part, and then I don't think it went well how we imagined, but also thinking to accessibility issues or impairment, temporary even impairment. I just broke my hand and I cannot use a mouse and a keyboard, but I can first customize the interface so that, I don't know, it's bigger buttons or more touch screen friendly, and etc. So I can continue to use the same application even if in that moment I have some difficulties for whatever reason in doing that. So that was a little bit the spirit.
I like the first one. I think you're right that it's with this reaching for your phones, it is habit, isn't it? But your suggestion there is that it's to replace the habit with a new habit. Isn't the issue a lot of time with phone use that we're already doing something else and we stop that to look at our phone, like it's eating a meal and people sit with their phone on, and so it's not you need to add more stuff, it's that you need to be less.
Yes, and that is actually one of the problems this kind of works is that they use technology to try to fix technology. So you create a smartphone application to reduce the use of other smartphone application. That's true. Indeed, two areas that we are working on right now. One is on the education side with school, we have a national project in which we try to have teachers and students working together on digital well-being effort with customization for the teacher so they can decide what to do, in which way, more competitive, less competitive, and which topic to cover from a list of possible topics, and then students can have, so put it in the classroom at high school level in this project. So education is another option so that to use less. And the other direction we are taking, that is not related to personalization though, is about designer of user interfaces. So there are patterns that are deceptive and we do them for money. And so recognizing that there are these patterns that capture our attention and keep us on the phone and informing design. At the moment, we are thinking of informing designer that they are doing this kind of thing. And then, of course, the designer as the agency and someone above them probably to decide, okay, I can maybe skip these, I can use another alternative. So we are working on design patterns for designer. There is a lot of work we are doing on digital well-being, especially my colleague here. My colleague Alberto is like leading the digital well-being effort that we started together in 2019, but now he's an assistant professor in tenure track, so he's on like field and is exploring all these topic, partially with me, partially without.
There's a question online.
Yep.
Thanks for such an interesting talk. I'm curious whether when conducting the digital well-being study where participants identified meaningless habits, you got insights about why they developed these habits in the first place, and whether you saw patterns in people having similar habits they wanted to change. Question by Joanna.
Can you say again the second part?
So you got insights about why they developed the habits in the first place and whether you saw patterns in people having similar habits they wanted to change.
The last one, I don't think. I'm going to by memory, of course. But for the first one thing that I didn't add in the slides, but that we analyzed was these motivations. And so the most popular reason was I'm bored. That was the top most reason that people gave for which they developed this habit. I'm bored, and so I scroll social media. That was the top reason they do that. And for the activities, the top activities that people say write in that part was something around studying or working, so replacing Facebook in this case with study 3 pages or something like that. And the second popular activity was some specific activities like go for a walk, do a stretching for 5 seconds, etc. So, but most of these start from I'm bored.
So that's the issue. It's about intentionality.
Yeah.
And sit back, entertain me.
Any other questions? Okay.
Yeah, no, I just saw there was a reply to that. That's great, thanks. I then wonder if they were bored from studying and they try to fix it with studying.
But maybe that's we should look back to what they said and in the experiment. But for sure, it's something that like 10 a.m. in a week during the week, you're bored for the activity that you probably are doing. So probably they're bored to study and use this to change time to do something different.
Okay. Well, thank you very much for a really interesting talk. And thank you to the people online for joining us as well.
Thank you all.